Section 6.3, the quadratic formula. This is standard quadratic form where it's in descending order. That means that the second degree is the first thing you see, and then the first degree term is the second thing you see, and then the constant will be last. It'll all be on one side, set equal to 0. The quadratic formula will tell you when you plug in a, b, and c what the possible values for x are, and it is as follows. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to solve this equation. First it needs to be set equal to something. I'm going to set it equal to 0. That'll be what we start with. But I'm going to solve it not using the quadratic formula. I'm going to solve it in the way we've done before, and that's by factoring. So it has a greatest common factor of x. I factor that out. And then I'm going to use the zero product rule. If two numbers have a product that's equal to 0, then one of them must be 0. We don't get to pick. We have to do both. So we set this factor, x, equal to 0. We set the other factor, x plus 3, equal to 0. And then we solve each. Now the first one doesn't require any solving. It's already done. X equals 0 is one of the solutions. And the other, we subtract 3 from both sides, and we get x equals negative 3. Now if I were to graph those two solutions, and I know this isn't checking the solution, but I'll bring up a graphing calculator to check it. Then it has to go through the origin and through negative 3. So here's one way we could graph sometimes. Is if you already know your roots and you want to find your axis of symmetry. Well, these are 3 apart, so you're going to go halfway in there because I would have reflected one of these points over a line. That would be right there. So my axis of symmetry would be here. And I would plug in x equals negative 1.5. Or so 2 times 1, 3, or it's 2 times 1, 2 plus 1, 3, so negative 3 halves. So plug in the negative 3 halves into this function. We'll square it. So I'll have a negative times a negative is a positive. 3 times 3 is 9. 2 times 2 is 4. Then plus 3 times 3. But it was a positive, this positive 3 times this negative 3. So plus a negative 9 over 2. Then I will make these terms have a common denominator. So I'll multiply by 2 over 2, just another form of 1, and this becomes negative 18 quarters. So 9 quarters plus a negative 18 quarters, that's going to be negative 9 quarters. So my vertex, it's going to be on the axis of symmetry, so it has this x value, negative 3 halves, and the y value we just got from plugging the x value into the function, negative 9 quarters. Well, those are kind of unfortunate points to be able to, by hand, see if it lands here. So let's see, negative 9 quarters is negative 2 1/4, so about right here. And then we want to see if we actually get that as a graph. So what I'm going to do is I'm going to bring up a graphing calculator and show you that we do. And looks pretty much like what we have here. Through 0, 0, through negative 3, 0. So yeah, it's kind of hard to graph that one by hand because we're going to, if we're using the A rule from here, we're just going to miss that point. We're going to go over 1, up 1, and reflect. Then we're going to go over 1 and up 3. Let's see, 1, 2, 3. We're going to hit here. So we actually don't hit those 2 red points, which were the roots. So our graph would just be an estimate. Okay, so we did not graph that one by convention that I've shown you before. This time we graphed by finding the roots, plotting them down. The axis of symmetry is halfway in between, That's a little bit different than using x equals negative b over 2a. But if I did use x equals negative b over 2a, I would have gotten this negative 3 halves and could have plugged that in just like I did to get the negative 9 quarters. Okay, we also did not solve this using the quadratic formula, which this section is about. No, we solved this one by factoring, because factoring is going to be a pretty quick way to get there. So we will solve some by the quadratic formula soon, and I'll tell you when you want to do that. All right, here's some problems that you probably know how to do. If you think you do, then pause right here and go ahead and give it a try. If not, then just hang on for a couple seconds and we'll get started. Okay, so a couple things you got to consider. This negative right here, it's going to be an imaginary number. This 8 and this 24 inside the radical, they both have perfect squares in them. They will come out, so that's the second thing you have to consider. And another is, what do you do with the denominator? And the answer is that denominator is going to have to divide both of the terms. The 4 6 will simplify, and something will come out of that 8, and we'll simplify that with the 6 as well. So let's get started. Square root of 8 is 2 radical 2. That's one you've seen a couple times now. And the 6 divides both that 4 and that 2, so I'm going to write it in another step where I give each of those terms that 6 is the divisor. So 4 6 simplifies to 2/3. Keeping that plus or minus the whole time. This 2 6 simplifies to 1/3. Careful though, you cannot simplify this. This is not the number 2, it's radical 2 or square root of 2. This is irrational, this is rational. You cannot divide the two. So, okay. The 2 6 simplifies to 1/3, and there's no real reason to write the 1/3. If you do, well, you can keep it there, it's fine. There, I wrote it in yellow so you can hardly see it. So, have it there, don't. I'm not going to have it there. So there's our answer. Okay, this one, the square root of 24 is the square root of negative 1 times 24. Well, I meant to say the square root of negative 24. So I'm going to take that negative 1 out, and then I'll deal with the square root of negative 24. Now you have to remember that I is equal to the square root of negative 1. So this negative is just going to come out as an I. It's pretty simple. If you have a negative inside the radical, out comes an I. So for the 24, I'm going to make a factor tree. 8 and 6. 6 is 2 times 3. And 8 is 2 cubed. So I'm just going to make 3 branches there. And I am going to do pairs are squares. Every pair I see gets crossed out, and that meant that it was the square root of that thing squared, so out is going to come that number. So out will come a 2. It happens again. Out comes another 2. But in stays this number because it did not have a pair. So I'm going to simplify this. It's going to be 4i radical 3, and then the rest. So I have 5 plus or minus that 4i radical 3 over 2. Unlike last time where I had even numbers in every term, this time I don't. So I have two options. I could leave this as an answer, or another option is I could say each of these terms is divisible by that 2, so I give each of the terms, the 2 is the divisor. This simplifies, the 4 halves becomes 2 over 1, and the rest just carries out, 2i radical 3, and then the 5 halves. So either that answer above or this one, both of them are fine. So for this last one, the 17 is prime, so nothing comes out of the radical. So I could do like this and just say, since I'm not going to simplify anything here with that 2, I could just leave that as the answer. But an alternate answer is you give that 2 to each of the terms in the numerator. Doesn't simplify anything here, but here I have a 2. So 2 plus or minus the square root of 17 over 2. Okay, we're going to solve and graph each of these. Let's see. We're going to try to do it by factoring, what we've known how to do before. So we are going to get it in descending order, standard quadratic form. And then we're going to see if we have factors of 8 that have a difference of this 2 here. Our factor pairs of 8 are 1 and 8. 2 and 4, and that is it. But right here, yeah, 2 and 4. So one of these gets a 2, the other gets a 4. Doesn't matter what order. When I multiply the 4 and the 2 together, it has to be negative 8. So one of those two numbers has to be negative, and the other one's got to be positive. Well, when I add them together, I get a positive 2. So it must be a positive 4 added to a negative 2. So here's how it factors. So from these factors, I get roots. Set x plus 4 equal to 0, and that gives me x equals negative 4. Set x minus 2 equal to 0, and that gives me x equals 2. Alright, so negative 4 as a root, positive 2 as a root. They are 6 apart, so half that distance would be 3. So that means my axis of symmetry, unlike our first try, is an integer, and that's kind of nice. So my vertex, I need to find that. That's going to have an x-coordinate of negative 1. And then I'm going to plug the negative 1 back into, I like this line right here. And we'll see what we get out. Negative 1 squared, negative 1 times negative 1 is 1. And then I'm going to have a 2 times a negative 1, that's negative 2, and then minus 8. Okay, so that's going to be off our chart. We're going to have negative 10 plus 1, so we're going to get a negative 9. Do I have enough room for that? 1, 2, 3, 4, 5, 6, 7, 8. Nope, and it goes down below the camera, so 1 second here. Alright, so that went down to 8, and I wanted 9, so that would be right here. And then the A is 1, so over 1, up 1, and I'm back onto the grid. And then over 1, up 3, 1, 2, 3. And then over 1, up 5, 1, 2, 3, 4, 5. You'll see I landed on the point that I already had. This is more convincing than the last graph, where I actually get to land on the x-intercepts, the roots. And I've got my graph. Alright, so we're in a section about the quadratic formula, and I've given you the quadratic formula, but we've not yet used it. So let's see what that's all about. Let's try this one. We're going to try this one by factoring. What you're going to find is it doesn't work. 5 is a prime number. Its only factor pairs are 1 and 5. But when I multiply them, I've got to get a negative 5. So one of these has to be positive and the other negative. And when I add them, I've got to get 6. Well, that doesn't happen, because if I have a negative 1 and a positive 5, the sum is positive 4. If I have a negative 5 and a positive 1, the sum is negative 4. So this one just doesn't factor. We're actually going to have to use the quadratic formula to solve this one. So we're going to do that on the next video. So come back and see you then.